Hello, my name is Dan Walsh. Today I'm going to be demonstrating the use of containers on a Red Hat Enterprise Linux 7 system. We're going to be showing you different namespaces that are used to create the concept of a container. I will be demonstrating 4 different namespaces during this presentation. I've set up 2 terminals on the screen. The top terminal is actually the host operating system where we'll be running the containers, and the bottom terminal is actually the container that will show the stuff happening inside of the container. So I'm going to use the virt-sandbox-service tool to actually enter the container here. So the container was created with virt-sandbox-service, and now I'm going to be entering the container. So you see here, the name of the container is going to be httpd_container1, and I'm about to enter a shell inside of it. If I look in the container, the first namespace I'm going to talk about is called the host name namespace. What host name namespace allows you to do is actually set up a different host name for each container that you're running on a system. It also allows you to set up different domain names for each container that you're running on a system. So I went to my host machine and I ran host name. You would see that the machine name is Patriots. But inside of the container, when I run host name, you'll see that it's httpd_container1. So I've been able to isolate and allow people to figure out which container they're running on based on the hostname command. And a more interesting container namespace is a thing called the process namespace or PID namespace. This allows processes to change their proc/proc table and actually have more than one PID once. So if I go inside of the container now and I just do a ps-ef command, I will show that all the processes are running inside of the container. In this case, I have you'll see a systemd running and a systemd journald, and then a bunch of Apaches, and actually the shell that I'm currently executing and the ps command that I just executed. Notice that virt-sandbox-service starts up a systemd and starts up individual services, one or more services inside of a container, but you could actually set up containers to run all different types of processes. Outside of the container, if I went and looked at how many processes are running on a system, you would actually see that we have quite a few more processes running. In this case, we have 205 processes. So from the container's point of view, it's only seeing the 7 or 8 processes running on it. Another interesting concept here is if you notice inside of the container, we have systemd running as PID1. But if I went outside the container and looked at the processes running, I'd see that there is a real PID1 running on the host machine. It's running as PID1, but in this case, the systemd is actually running as 29136. This means that what the kernel is actually doing is it knows the host is actually able to see all the processes running on the system, including the processes running inside of the container. But inside of the container, the kernel sort of tells the processes the PID1 inside of the container is systemd, but outside of the container is actually running that process with a totally different process ID. So that shows you the process namespace. You could also go up to the /proc and look around inside of the container, and you would see very few. Here we see that there are very few processes running, as opposed to the /proc out here. You see lots more processes running. So that is the process namespace. The next namespace I'm going to show you has actually been used for many, many years, and that's called the file system namespace. What the file system namespace allows you to do is change the mount table inside of a namespace. So a process is able to ask to join a file system namespace, and then it can start mounting files or mounting file systems or mounting files over other files, and actually have a totally different view of its file system than its parent. In a virt-sandbox-service container, we actually use bind mounts for a whole bunch of file systems. So if I went and say looked at the root directory, I'd see that there's nothing in there. If I looked at home directory, you'd see that there's nothing in there. If I go up to the host name and looked at the root, I would see that there's some files in there. Similarly, if I looked at home, on here, I would see that my home directory is there. One of the big directories that I mount inside of a container separately for each one of the containers for the virt-sandbox-service is var, and we do this so that, so if you looked at this var, you'd see a whole bunch of files, but if you look at the var on inside of our container, you would see far less files. And what we've actually done here is we've actually bind mounted file systems. We created up a file system down under var lib file systems container name /var, and we're actually bind mounting this directory on top of /var. So if I inside of this directory here was to create content and went over to this directory and then this /var, I would see the content being created. Similarly, if I inside the container, I can then remove the content, and as you see out here, the content gets removed. So by using file system namespace, I'm actually able to change the world view of the process inside of the container from what its parent processes see. Another interesting thing you can do is actually remount things like the / file system. So if I went up to / on this container and tried to say create a file or a virus on the system, it would tell me that the file system is read-only. So one of the things we do when we set up a virt-sandbox-service, one of the first things we do is we actually remount the entire operating system, or the file systems, as being read-only, so we prevent containers from being able to write in random locations on the operating systems, and then we set bind mount other directories into the container that are writable by the container. The next namespace I want to talk about is called the network namespace. And what a network namespace is a really powerful concept, because basically I can assign IP addresses to processes to the container on the namespace, and actually set up whole different IP stacks and whole different routing tables, things like that, for our processes inside of the container versus processes outside of the container. So if I go inside of my container here and did an if config eth0, you would see that it's been assigned the address of 192.168.121.122.1. And if I go outside the container to the host and did an if config eth0, eth0 doesn't even exist. In this case, actually the main Ethernet address of this machine is actually assigned to P1, and it's 10.19.60.74. If I tried to see that inside the container P2, P1, I would not be able to see it, because that device doesn't even exist inside the container. So with the beauty of the network namespace is I actually can set up, as I said, routing tables. I can even set up entire IP table stacks of controls inside of a process. So I could set up a container running on my host machine where the processes were only allowed to connect to, say, my internal network, whereas the host is able to connect to the external and the internal. So if you thought about running a container, say, on a demilitarized zone, you could actually set up routing tables such that the processes inside of a container could only talk to the internet and would not be able to talk to your internal network. So these four concepts of host name namespace, PID namespace, file system namespace, and network namespace sort of set up four of the core namespaces used in containers on a Red Hat Enterprise Linux 7. Thank you.